Hello, welcome to the week 9, and this week 9 is going to be consist of two parts, and the first part we are going to talk about the priority queue, and the second part we are going to talk about the binary heap, in short heap, right? So our objectives are this. So we have been studying various types of the data structures, for example, linked list, stack and queue, and recently binary search tree, right? And we are going to add one more to our data structure portfolio, which are not one, two, which are binary priority queue and heap. All right. So these are the two things that we are going to focus on in this week. So the first part we are going to cover the priority queue, and the second part we are going to cover the heap, in particular binary heap. Okay. So yeah, I got a student response about the please stop saying okay. So I will try to do that, right? So objectives are these. So understanding the structures and the operations of priority queues and heaps. So at this moment, up to this point, you have pretty well kind of understand that if you want to run something about, if you want to run a certain data structures, you have to understand its structures and its operations, right? So these are really the two aspects of the things that you have to know to implement and to utilize a certain data structures. So here we are going to study the structures and operations of the priority queue and heaps, right? And in particular, we are going to study insertion and deletion. So in the rest part of the lecture, we talked about the traversing, right? And traversing, and here we don't have that operations in particular. And at the same time, find min and find max are not going to be supported here because that it has a special characteristic of the binary queues and heaps, all right? And finally, you have to understand the performance of the priority queues and heaps, all right? So let's start. So first thing first, priority queue, right? So queue, this thing is pretty familiar with you, right? Queue is quite familiar with, and this we are adding this priority to the queue concept, right? So before we start, we are going to check the performance for a little bit. It's the rest slide of in the rest lecture. It's performance of the binary search tree, right? So far we have the linked list and binary search tree, and binary search tree in worst case. This is the average case, right? Binary search tree in average and binary search tree in worst case. In this case, it's nothing but almost equal to the linked list, right? Linked list basically navigates through by utilizing the getNext method, and this binary search tree has go to left hand side or go to right hand side, but it only utilized to go to the right hand side operations. So it means that we are never going to utilize left hand side. It means that right hand side is just another type of the getNext, just like in the linked list. So which is showing almost the same performance along this line, right? However, if you are smart about using the binary search tree, these things get changed, because that by adopting the divide and conquer concept, you can minimize the search, right? If you want to find 4 here, you know that 4 is not in the left hand side, so you can eliminate the search around here, and then you come here, and then you know that 4 is never going to be on the right hand side of the 5, because in the right hand side, always numbers will be bigger than 5, right? So we can eliminate the searches around here. Means that we can narrow down the search corridor, search path to the 357. It means that we can search through by not iterating the whole list. So eventually the maximum search space is going to be the path, the maximum path length in the tree structure, and the maximum path length is going to be the height, and the maximum height is going to depend on the log of size, which is going to be log of n, right? So that's the things that we have been covering so far, okay? So this performance is coming from the divide and conquer. Having said that, let's continue our discussion about the priority queue. So priority queue is this. So this picture is, you have seen this picture somewhere, right? This is coming from the queue, right? Q-E-U-E. And this person is here, here, here. By looking at the direction of these people, this person, Professor Tasigri, got here first, and Professor Ha Yong-shin is next, and Professor Il Chul-moon is the rest of this line, right? So the kind of expected order of the arrival is this, in Q-ri, and in Q-shin, and in Q-moon. And then there is a DQ process here, and then the queue is going to be empty. So it's pretty normal, and you can implement this with the linked list and so forth, right? However, let's imagine that we have another person here, and this person is a very important person, and what happens in the real world is that, okay, we get cramped to the back here, and this person is going to be the first in the line. Means that this person has priority, right? You see that if you purchase an expensive seat, then you will probably get served first than the others who purchase tickets with lower price. That happens in usually in the airport, right? And what happens is here, is listed here. So in Q-ri, in Q-shin, and in Q-moon happens at normal, right? However, at this moment, in Q-ri happens and with priority, means that these three persons don't have that priority. It means that this person with priority is going to be at the front of the queue, right? So there is one particular word that epitomizes the characteristic of the queue, which is called FIFO, right? Can you recall what does this mean? This is first in, first out. That's what it means. First in, first out. First in, first served, right? However, even though Professor Tasigri here got here first, he is not going to be the first one who gets out. Rather, this person gets here the latest. However, he is going to get off first, right? This. And then that ends. So this shows how we can handle the case with priorities, element who has priorities in queue operation. Naturally, the element with the priority will be dequeued with the priority as well. So that's the person who is going to get off first. Often cutting in the line or VIP service. This is in Korean is called 세치기, right? Anyhow, that happens in the real world.